1 over a to the n, and we get a to the negative n. The rule is really simple. It's just you need to understand that this negative sign stands for taking reciprocal of any number. So for example, anytime you see negative, it means that you take reciprocal, meaning 1 over something. And this, like in this case, a and n, you're just going to put in denominator. So let's do a couple of examples. Let's say you have 1 over 10 to the third. So in this case, you're going to say that I'm just going to use this rule above. So it means that 1 over 10 to the third, so will be a is in denominator and a is on top. In this case, 10 is in denominator, just like a base. So we are going to use this 10. And then we are going to use same exponent n, but with negative, with opposite sign. So it was positive 3, it should get negative 3. So that's, we just apply this basic rule. Another example is going to be this 1 over 10 to the negative 5. Same idea. We take 10. And again, what should happen is we take this negative 5, we bring it to the 10, but make sure to change the sign along the way, 10 to the 5th. There is actually problems that could be done a little easier version of it, because just like we spoke in lesson 1a, we have one, basically if you have 10 to the 0, it's equal to 1. So anytime you see 1, you can replace it with something like 10 to the 0, because anything to the 0 power gives us 1. So instead of using 1 on top, we can actually write down 10 to the 0 divided by 10 to the third. And as of right now, we just wrote using previous rules that we talked about, division of exponential notations. So we got 10, and we just subtract exponents. 0 minus 3, the answer is negative 3. And this is exactly what we write down. And notice that the answer is absolutely the same. Same should be done for this one. Instead of 1, we are going to write down 10 to the 0 divided by 10 to the negative 5. So in this case, we write down same base, 0 minus negative 5. Make sure to change minus and minus to the plus. So it's like 0 plus 5. So we got 5. And again, this answer and this answer is matched. Okay, so right now what we are going to try to do, we are going to mix up all of the rules and try to use them all together. A. 2, okay, let's say 10 to the negative 3 divided by 10 to the 5th times 10 to the negative 2. Okay, so there are many ways of doing this problem, but the best way is to combine top, combine bottom, and then uh, finish calculation by applying top and bottom rule. So it's like going to be division rule. So it's 10 to the negative 3 on top. There is nothing really to change. We are going to keep it the same. In the bottom, it's multiplication of exponents, multiplication of bases in this exponents. So we keep same base 10. But for exponents, we should add them. 5 plus minus 2 gives us, so notice that 5 and 2 have different signs, positive 5, negative 2. So we have to subtract larger number minus small number. So it's 3, and we keep a sign of a larger number. So 5 is positive, 5 is greater than 2. So that's why 3 is a positive. So it's 10 to the third. And right now, it's the basic division. So 10, and we have negative 3 on top and 3 in the bottom. So it's negative 3 on top minus 3 in the bottom. Same signs, negative and negative. It means that 3 and 3 should be added together to give us 6. And we should keep negative sign overall, and that's the signs that we keep it. So we got 10 to the negative 6. And that's final answer. Let's try B. 10 to the negative 3 times 10 to the negative 4 divided by 10 to the fifth times 10 to the negative 8. So again, let's calculate top first, and then we'll get the bottom. So multiplication, we keep the same 10, negative 3 plus negative 4. So let's do it on the side. Negative 3 plus negative 4. So this is negative and this is negative. So 3 and 4 should be added together, 7. And you should keep sign of overall sign. This is negative, so this has got to be negative as well. So 10 to the negative 7. For bottom, same thing. We keep 10 for base, 5 plus negative 8, different signs. We should subtract 8 minus 5 gives us 3. 8 is a greater number and it's negative, and this is the sign as is that we keep. So it's negative 3. Now it's simple division, so we got 10, negative 7 plus minus, because it's division, negative 3. In this case, don't forget that negative and negative gives us positive. Negative 7, again, different signs, so we need to subtract larger minus smaller. So we get 4, and we give sign of a larger number. So the answer is 10 to the negative 4. Another problem. 2 to the fourth, 2.4 times 10 to the negative 3 multiplied by 3.5 times 10 to the 23rd. So notice that in this case, it's simple multiplication. We don't need to change any exponents. We can just work the way we see it. We could just combine 2.4, you could just combine numbers together if you wish. And then you can just combine exponents together. Because it doesn't matter if you multiply 1 times 2, you get 2. 2 times 1, you also get 2. And then we can just organize it by placing parentheses around it. So 2.4 times 3.5, you're going to use calculator, or you can just calculate it by yourself. We get 8.4. And for this, it should be negative 3 plus 23. Negative 3 plus 23. So we get 20. And that's the way we get 10 to the 20th power. Next, let's continue to the next problem. Problem D. We got 2 times 10 to the third multiplied by 4 times 10 to the 23rd. So this is exactly the same problem as we did before, same type. We just combine numbers together. So in this case, we combine 2 and 4, and we combine 10 to the third and 10 to the 23rd. You can use parentheses if you like. So 2 times 4 gives us 8 times 10, and it comes down to just addition of exponents, just because it's multiplication of same basis. So 3 plus 23, the answer is 26. So the answer is 8 times 10 to the 26. Next problem. 6.5 times 10 to the 23rd divided by 4.1 times 10 to the negative 8. So in this case, we should divide these numbers and then work on this exponential notations. So 6.5 divided 4.1 divided by 4.1 times 10 to the 23rd divided by 10 to the negative 8. So in this case, if you take 6.5 and divide by 4.1, you should get 1.6. You can do it manually, you can use calculator for this, times. And right now we just write down 10. It's division of different exponents, but same basis. So we should be able to subtract 23 minus negative 8. Negative and negative gives us positive. So 23 plus 8. And if you add it carefully, you should get 31. So this is 31st power. And the problem is done. Last, problem F. We got 10 to the negative 14 over 2.0 times 10 to the negative 8. So in this case, notice this bottom part is scientific notation. And on top, we don't really have scientific, I mean, it's sort of scientific notation, but it's just sort of exponential part. So just to make it look like scientific notation, we know that if you multiply anything by 1, you get the same number. So over here, you can just multiply it by 1 because 1 doesn't really affect things. So, and right now it just comes out to be the same problem as before. We get 1.0 divided by 2.0 times 10 to the negative 14 over 10 to the negative 8. So we just split. 1 over 2 gives us 0.5 times 10. And right now it's only negative 14 minus negative 8. So basically negative gives us positive, and it's negative 14. Different signs, minus and plus, so we gotta subtract larger minus smaller. 14 minus 8 gives us 6, and we make it negative 6 because 14 is a larger number than 8, and we keep a sign of a larger number. So we write down 10 to the negative 6. And all we need to do now is to fix this scientific notation because it's improper. So we push this one to the right, making it, let's say 5.0, if you could just say 5 times. And in this case, this number was increased by 1, and this number should be decreased by 1. But see, make sure that if it's negative 6, if you decrease it by 1, you get negative 7. So it just should be decreased by 1. And we needed to make a change just because 0.5 is a proper scientific notation. First number cannot be 0, but right now it's not 0. 5 is non-zero number. So this problem concludes lesson 1B, which is calculations using exponential notations.